In this video, we'd like to understand a special distribution which is part of normal distribution known as the standard normal distribution, and would like to understand some of the steps that one has to take to figure out a solution to a given problem. So standard normal distribution is a distribution which has zero mean, it's centered at zero, and the standard deviation is 1. So that's standard normal distribution. It's normal, of course, but it's standardized in the sense that it is centered at zero, and the standard deviation is 1. And so when you plug this mu equals 0 and sigma equals 1 into the PDF of a normal distribution, you get the PDF of the standard normal distribution. So that's what a standard normal distribution looks like, the PDF of the standard normal distribution. Now, why is this important? Because every time we face a problem, we would end up using this standard normal distribution to figure out the probability that we are interested to find out. So when you have any x, for example, any x, the first step to understand the probability space of that x random variable is to convert this x to this standardized value. So each x will have its own standardized z value. I will use the letter z, special letter z, to denote standard normal distribution. And this z value, z score, is nothing but you take the value of x, take away its mean. So now when you take x minus mu, you are centering it, and then you divide by the standard deviation of this x random variable, and that will give you the standardized value of each of the x's, right? The next step would be to look at is to get the probability of z using the table, right? So what do you mean by probability of z? So there are three possible situations that one can face. One could be a situation where one is interested to find out probability that this standard random variable takes a value less than or equal to 1, exactly equal, less than or equal to 1, and that is given by this shaded area. We would want to find out how much is this shaded area in the first example, in the first case. The second situation one might face is that one is interested to find out the area which is between two values of the standard normal. So here we have a situation where we are interested to find out how much is the probability of this standard normal standard random variable taking value between negative 0.5 and positive 1.25, right? So it's basically this area which is again shaded in the second example. Of course, keep in mind the center point is 0. That's what a standard normal is about. And in the third case, one could have a situation where we are interested to find out the probability that z takes a value greater than or equal to 1.58, right? So in the first case, we are interested to find out the area to the left of some point on z. In the second case, we are interested to find out the area in between 2 points in the standard normal scale. And in the third example, we are interested to find out the area to the right of some point on this bell curve, right? So you can look at my other video that deals specifically with how to read this standard normal table and also t-distribution table. But here you would recollect or probably know that the table that is given for standard normal is always going to give the area to the left of some value, right? So you look at the value 1.0, so the row in the standard normal will be 1.0 and the column will be 0.00 because that's what you want, 1.00, and that will, when you look at that entry, it will be 0.8413. So this area to the left of 1 is 0.8413. Then in the second case, we are interested to find out the area between two values of z, and table is always going to give you the area to the left of certain value. So here we would find out first the area to the left of 1.25. We find out the area to the left of negative 0.5, and then the difference of the first and the second will give you the area in between. So basically, which means in terms of notation, if one is interested to find out probability between two values of z, then it's probability that z is less than or equal to 1.25 minus probability that z is less than or equal to negative 0.5, because that's what the table will give you, area to the left of some value of z. Now when you look at the row 1.2 and the column 0.05, that will give you 0.8944, and when you look at the negative side, you look at a row called 0.5 and column called 0.00, you get to be 0.3085, right? So this area is 0.3085 graphically, and this area is 0.8944, area to the left of 1.25, and hence the area between these 2 points is 0.5859. Okay. By the same logic, again remember what the table gives us is the area to the left of some point, correct? And here we are interested to find out the area to the right of some point, and so you can easily use this idea of probability space, which is area to the left plus area to the right is equal to 1, and hence if you are interested to find out this area, that is 1 minus area to the left of 1.58, right? So that's 1 minus 0.9429, and hence this will be 0.0571. So this area is 0.0571, this area is 0.5859, and so that's how we figure out the probability for any given random variable x by converting into z and then getting the probability using the table. You can have any of these situations, and that's you exhaust all the possible